Alright, in this video we'll be looking at our 7th grade week 19 math review. We will be looking at day 1 and day 2. The first group of problems say simplify the fraction. That is, we'll find some number that divides into both numbers. For instance, 15 over 55, 5 divides both of these numbers. 5 goes into 15 3 times and 5 into 55 11 times. What we're saying is 15 over 55 is equal to 3 over 11. These fractions are equivalent. Alright, I think you can handle that first section of problems. The second section says simplify using order of operations, PEMDAS. Parentheses, exponents, multiply and divide happen together from left to right, and addition and subtraction happen together from left to right. First operations in parentheses, then exponents. Multiply and divide happen together, addition and subtraction happen together. Alright, so looking at this third one here, we have 2 to the third power, subtract 8 inside the parentheses. So the first thing I will do in the parentheses is the exponent operation. 2 to the third power is equal to 8. So I'm only going to change that part. 4 remains the same. 2 to the third is 8 because 2 times 2 times 2 is 8. Minus 4 divide by 8. Alright. Next I will do operations inside the parentheses. So 8 minus 4 is 4. This 4 remains the same. 8 minus 4 is 4. Divide 8. Alright. Now, these happen left to right because we have a multiply. I know they're multiplied because they're connected. Then a divide. Alright, so 4 times 4 is 16. We still have divide 8. And 16 divided by 8 is 2. So 2 is my final answer here. In this last line, the multiply doesn't happen first because the m is first. The multiply happens first because it is on the left. If we have a multiply and divide in one line, we go from left to right. 2 is my final answer there. Okay. The bottom group says write a numerical example that demonstrates each property. Well, the commutative property says that the order doesn't matter with regards to multiplication and addition. So I'm going to do one and I want you to think of another example. So a illustration of the commutative property is this. 4 plus 3 is equal to 7, and 7 is equal to 4 plus 3. In these problems at the bottom, we're going to come up with numerical examples of each of these properties. The first property is the commutative property. The commutative property states the order does not matter when we're multiplying and dividing. For instance, 4 plus 3 is equal to 7. 4 plus 3 equals 7. But also, 3 plus 4 is equal to 7. Notice I rearranged these two terms with my addition, but I still have the same sum. You come up with your own example of the commutative property. The associative property says that with multiplication and addition, grouping doesn't matter. So, for instance, 4 plus 3 plus 2 is equal to 4 plus 3 is 7 plus 2 is 9. Likewise, 4 plus 3 plus 2, but let me this time group the 3 plus 2, and I should still yield 9. Well, adding 3 plus 2, that's 5. 5 plus 4 is 9. So these two illustrate the associative property. Whether we group the 4 and 3 together, then add the 2, or the 3 and the 2 together, then add the 4, we get the same sum. You come up with a similar example of the associative property. Next is identity for adding. The identity property for adding states that whatever you add 0 to, you'll get back that term. For instance, 5 plus 0 is equal to 5. The distributive property states that if we have some term times some parentheses, it is simply equal to this term times each one of these and then some. So 4 times 2 plus 4 times 1. Well, what is 2 plus 1? That's 3. And what is 4 times 3? Well, that's 12. Let's see if we get the same thing on this side. 4 times 2 is 8. 4 times 1 is 4. And 8 plus 4 is indeed equal to 12. Alright, the distributive property says if we have a number multiplied by parentheses and we have an addition or subtraction inside the parentheses, we simply take the term outside and multiply by both inside. 4 times 2, 4 times 1. Alright, one small error in this top one. It says multiplication. I should have shown some sort of multiply over here instead of my addition, and I will make that change at this time. Alright, we can use the same 4 times 3. 4 times 3 is 12, but so is 3 times 4. So we see that with both multiplication and addition, the order does not matter. We can switch the order of the terms. Alright, now day 2. Okay, these top all involve multiplies and divides. We know that when we're multiplying or dividing, if the signs are the same, a positive times a positive, the product or quotient is a positive, negative times a negative yields a positive, but whenever the signs are different, we yield a negative. And we can reverse these. We just illustrated that with the commutative property. So if the signs are same, it's positive. The signs are different, it's negative. That's with multiplying and dividing. Thus, negative 6 times negative 4 is a positive 24. But positive 32 divided negative 8 will be a negative 4. Signs the same, positive. Signs different, negative. Okay. Second group here. Solve each inequality and draw a number line. I'm going to do one like number 1 here, and you can do number 1. So let's say it was x minus 7 equals 10. I'm doing one like this one. You can do this one. I should have not an equals, but a greater than in this case. Changing my equals to a greater than. Okay. Solving for x, I want to get rid of my subtract 7. I will add 7 to both sides. 7 cancels with 7 to leave x. Preserve my greater than. 10 plus 7 is 17. Now I want to graph this inequality. I want to graph values x greater than 17. Here's 0. I will put greater than 17 on the right hand side, and then I'll graph one value on the left. This will be enough. I want values greater than 17. Well, that's values to the right. So I'll put an empty circle over 17 because we have no equals to, and I want greater than, and that would be in this direction. Okay. This inequality is all values x greater than 17. Notice the inequality is kind of pointing in the direction that we're shading here. Okay. Any value in my shaded region will satisfy that inequality. Remember, when we multiply or divide by a negative number, we need to change the direction of inequality. I'm going to change this problem from 12 divided by x to x divided by 12. See if you can handle those. Convert the mixed number to an improper fraction. We simply multiply the whole number times the denominator, add the numerator. So 3 times 7 is 21, plus 5 is 26. This would be equal to 26 over 7. And then in the bottom ones, we're asking to go the other direction. 30 divides into 35 one time with 5 left over, so we place that 5 over the 30. And 5 over 30 will reduce. 5 goes into 5 once, 5 into 30 6 times. So 1 and 5/30 is also equal to 1 and 1/6. 5 into 5 one time, 5 into 36 times. Alright, see if you can complete the rest of those problems.